We'll get started. Good afternoon, stargazers, and welcome to Eyes on the Skies, a Plato-Madison lecture from the director of the UW Space Place, James Lattis. I'm Joy Cardine, and like you, I presume, I am looking forward to learning more about the stars and constellations and other fascinating celestial objects that we can find in the night sky these days, as well as any other eclipses or meteor showers or other interesting astronomical events visible in the near future. If you have any questions or any observations that you'd like to report, please post them in the Q&A feature. That's at the bottom of your screen, and I will share them with Dr. Lattis after his presentation. Jim Lattis holds a Ph.D. in History of Science from UW-Madison and is the author of many publications in that field. He helped create UW Space Place, the Outreach and Public Education Center of the UW-Madison Astronomy Department. He has directed it since its founding. He manages the historic Washburn Observatory, teaches courses in introductory astronomy and its history, gives frequent public talks and interviews, including on my old stomping grounds, Wisconsin Public Radio. Thank you so much for joining us, Dr. Lattis. Anything interesting to see these days in the night sky?
Well, plenty. So that's what we're here to talk about. Plenty. Well, thank you very much, Joy. That's a fine introduction. And I'll just put in a plug for my History of Astronomy and Cosmology course. I'll be teaching that in the first summer term this year. So if anybody's interested in that, I can give you more information on that. So yeah, let's go to some slides. Let me get the screen here for my slides going. Oops, I think I didn't do that right. There we go. And I trust you'll let me know if you're not seeing my slides.
We see them.
Look okay? All right then. Well, right. So what I want to do really is just sort of take the year, although more and more of it is gone, of course, but sort of take the year in order real quickly and give you a survey of what's coming up. In May, it turns out, is going to be a particularly interesting month, so we're going to spend a little bit of time on that. But just very quickly, sort of up here for the record are some of my favorite sources for astronomical information. And they're all publicly available, so you can refer to any of these quite easily yourself. The software that I'll be using just a little bit later is called Stellarium, and you see the website there. And the top site is a website that publishes an annual guide, an astronomical calendar that you can find there. And then eclipse information, there's a website there for eclipse information. And if you don't know about it already, the NASA astronomy picture of the day is just a great astronomical resource, a little bite of astronomy that you can find every day just to start your day with a nice astrophotograph. So the year mostly, well, I should say not mostly gone yet, but a fair portion of the year passed already, and that's defined by these important astronomical moments, the equinoxes and the solstices. And it hasn't been that long ago that we just passed the vernal equinox, and so we're just starting now into spring, and we're seeing the sun higher in our sky every day at noon as we move towards the summer solstice on June 21st. And the days of course are getting longer. The earliest sunrise will come on the 14th of June, and 27th of June our latest sunset, and with the solstice right in the middle there. So this is just sort of a nod to the general progress that we have during the course of the year with the Earth in orbit around the sun, but finding the sun north of the celestial equator for a good bit of the year, and south of the celestial equator for the other half of the year. The notable a couple of notable events this year are eclipses. And so I'm going to spend just a few minutes talking about a couple of really fine, what turned out to be lunar eclipses this year. We have two particularly good ones. Whenever we have an eclipse, either of the sun or the moon, the fundamental fact that has to be true for an eclipse to occur is that the line between the sun and the earth, I hope you're seeing my cursor that I'm drawing on the screen with. If not, just follow that bold blue line to the lower left. The line from the sun to the earth, for an eclipse to occur, that line has to also pass through the diameter of the moon's orbit from what's called node to node. That is the points where the moon's orbit tips above and below the Earth's orbit. So the closer that exact alignment, the closer we will have to a perfect, to a total eclipse, either of the moon or the sun. But it doesn't have to be at just that moment. There's a little bit of time on either side of that perfect alignment when you can have eclipses. So we talk about eclipses happening when there's this window of alignment is possible. If you have a perfect alignment, and let's say have a total eclipse, so here we see on May 16th, we have a total lunar eclipse. That means the alignment is pretty close to perfect at that point, but it also means that either at the preceding or the following full moon, that there's a possibility of a solar eclipse. In fact, it's a high possibility of a solar eclipse. However, if you've got a really good lunar eclipse, then the solar eclipse either before or after it will be pretty crummy, will be partial. So that's what we have here. We have a total lunar eclipse happening on May 16th. And before that happens, just at the opening end of that eclipse window, we'll have a partial solar eclipse on April 30th. And I'll show you a chart of that in just a moment. In the other case, about 6 months later, we have another total lunar eclipse when the alignment is good. And so, as you would expect, there would be a partial solar eclipse nearby, and the same similar geometry applies here. The partial solar eclipse will happen just before, 2 weeks before that lunar eclipse. So the sequence is here. We have a partial solar, and you'll need to be in Antarctica to see that very well. Then we have a really good lunar eclipse, which will be really good for us here in Wisconsin. Then in October, we have another partial solar eclipse. And again, it's a polar thing, but in that case, the North Pole rather than the South. And then we'll have another nice lunar eclipse also visible in Wisconsin. So it's this alignment, this geometry that I wanted to mention is responsible for this not coincidental 2 week spacing here between solar, lunar, and then solar and lunar again. So let's take a look at those. Here's that partial solar eclipse. And as you can see, that is the one for April 30th. It's coming up here pretty soon. So you'll have to hurry up and make your plans to be in extreme, if you want to be on land, extreme South America down here or in the Antarctic Ocean in this area. That's the only place that anybody is going to see this partial solar eclipse. So probably not of too much interest. So we won't dwell on that. And similarly on the other one, the other partial solar eclipse that we'll have in October 25th. But in this case, the best viewing is from the northern polar regions. So here's the maximum eclipse right up here. And you got to be way up there in northern Scandinavia or Siberia to be able to see that one. So we're not going to spend any time on those. But the lunar eclipses are the ones that are going to be really great this year. Lunar eclipses are nice in general because unlike the solar eclipse where the total eclipse path is extremely narrow and you have to be in just the right geographical location to see it, lunar eclipses are visible from, in effect, the entire hemisphere of the Earth. And so it's not particularly critical, which is why you can usually just sit at home and wait for a lunar eclipse to occur, but you have to travel to solar eclipses. So the May 15th total lunar eclipse, here's the diagram that shows us the Earth's shadow. So the shadow of the Earth stretching out into space. When the moon moves through that, because of that alignment of the proper alignment of the moon's orbit with the Earth-Sun line, when the moon moves through the Earth's shadow, so this is the size of the moon relative to the Earth's shadow. When the moon moves through that, we get the eclipse. The darker, the red center there shows you what's called the umbra of the Earth, meaning the total shadow. That is, you're in deep shadow. If you were in this looking back at the Earth, you would not see any part of the sun. You would be in total darkness, in effect. And then in this region out here, this is called the penumbra. This is where you're in partial shadow. So if you were out here in space looking back at the Earth and you're in the penumbra, you would see some amount of the sun, from a little tiny sliver right near the umbra there to most of the sun, and then finally all of the sun when you exit the penumbra. So the moon will experience all these things as it passes through, makes this cross section of the Earth's shadow. Out here, the full moon will be in full sunlight. And then as the moon is moving in its orbit, that's what it's doing, it's just passing in its orbit through the Earth's shadow, it will become immersed in the penumbra, meaning that if you were on the moon there, at some given location on the moon, you would see a certain amount of sun, but the sun would be blocked by some amount of the Earth's body. So it would be in deeper and deeper shadow until finally the sun disappears. And here we say the lunar total eclipse begins when the moon has just moved into, when the last bit of the moon has moved out of the penumbra and into the umbra. And at that point, the moon is in total darkness. An observer on the moon would look back at the Earth and not see any sunlight. However, there actually is some light, and it actually is sunlight that is still perceived by this hypothetical observer on the surface of the moon looking back at the Earth, because the sun's light is bent around the edges of the Earth by the Earth's atmosphere and scattered into the penumbra. So despite the geometry, the penumbra is not completely in shadow. It's the deepest shadow, but it's not a total shadow. And so we see when the moon from the Earth, when we look at the moon during the eclipse, if the Earth's umbra were totally dark, we would not see the moon at all. It would simply disappear, be invisible, no light coming from it. In fact, the moon's disk is still pretty clearly visible because of that scattered light. And because it's light scattered through the Earth's atmosphere, it tends to be reddish for the exact same reason that the setting sun turns red. The Earth's atmosphere reddens the sunlight. And so that reddishness, that reddish light illuminates the moon. And depending on the conditions in the Earth's atmosphere at the time, one sees varying shades of red. This is why the press like to call such a total lunar eclipse a blood moon, which is way overly dramatic. And usually the redness is not anywhere near so deep red, but it does tend to have a reddish, yellowish tinge to it. So during the Earth's passage through the umbra there, we will see this nice eclipsed reddened moon, and then the moon will start to exit over on this side. So this penumbral eclipse, this part right over here, begins at about 8:30 p.m. on the 15th of May. And then the total eclipse begins about 10:30. So the moon will be immersed by about 10:30 p.m. And maximum eclipse, when the moon is most deeply immersed here, will happen at about a little bit after 11, called 11, I guess is the time I'm read off the chart. So a little after 11 there. And after that, then it sort of reverses itself, and the same phases happen in reverse, and it's over by well after midnight, early in the morning. I didn't even write in those times. By early in the morning, the eclipse is over. So this is the one to mark on your calendars, as you'll see in a minute. When I talk about the other one, it might be slightly less convenient hours. This is the one to mark on your calendars, and we have to hope we have a nice clear night on the 15th of May. If I'm not mistaken, I think that's still the plan. The UW Arboretum, I think we might be doing an event with the UW Arboretum that night, an eclipse viewing event over there. And they'll be sending something out about that or publicizing that but at the moment, I think we're probably doing something like that. But you don't need to be at any special place to observe such a total lunar eclipse. You can do it from your backyard to your front yard, wherever you can see the moon is the important thing. You can certainly usefully use binoculars and telescopes if you like. Binoculars uh, are nice for enhancing your view of the moon while it's eclipsed. Let's look at the second lunar eclipse of the year will come in November. And I'm not going to repeat all of that geometry that we just talked about in the other one, but here's the eclipse. Here's the moon moving through the Earth's shadow. You can see that it moves through about the same sort of amount, not perfectly centered in here, but well immersed into the Earth's umbra in here. However, this is maybe a little bit less convenient for a lot of us because the eclipse doesn't really begin until 2 a.m. and the partial then at about when the moon begins to move into the umbra, not until about 3 a.m. and maximum eclipse not until about 5 a.m. in the morning. So the event will still be in progress as the sun rises. So we won't actually see the end of this lunar eclipse because of, well, I guess we'll see it, but the sun will rise and pretty much spoil the show. But it'll be mostly over by then anyway. So this is the other nice total lunar eclipse. So we get 2 excellent total lunar eclipses this year. One of them coming up next month in May. One of the several notable things about May this year. So the problem with November is that statistically it's our cloudiest month. So but by the time we get around to the 7th or so of November, we should have a pretty good weather forecast, know whether it's worth getting up really early or staying up really late to see this lunar eclipse. We'll be taking questions a little bit later, by the way. So if you've got any questions about this eclipse stuff, just hang on to those and we will talk about them. In a few minutes, I'm going to use that Stellarium program that I talked about to illustrate what's happening with the planets coming up this year. And here I've just briefly outlined them, and I'll just sort of preview them right now, and then we'll go to I'll come back to planets after I talk about meteor showers. I'll come back to planets, but what's happening with the planets right now is that we don't actually have any bright planets in the evening sky. So here in April, May, really into June even, we won't have any bright planets in the evening sky, and I'll show you why that is in a few minutes. So there's not too much to talk about for planets in the spring, except that we will have a fairly good shot at seeing the planet Mercury towards the end of this month in April, right at the end of the month. And I'll show you how we could do that. Not a lot of people have seen the planet Mercury because it's very elusive, very hard to see. You usually have to take some special measures to see it, although it is technically visible to the naked eye. So if you're at the right place at the right time, you can see the planet Mercury. I'll show you how to do that if you want to go for that. But notice that's the only thing on my list in the evening sky then until we get around to August. In the morning sky is where all the action is happening, and a lot of that is happening pretty much as we speak. And we have really nice planetary groupings going on right now in April and right on into June. So we'll talk about those. I'll talk about all those. That's just a little preview. I'll come back to the planets here in a few minutes. Let's talk briefly, though, about meteor showers, because there's a couple of notable meteor showers. Well, one notable and then one slightly mysterious and possibly interesting, or meteor shower in the month of May. So coming up just next month, fairly soon. The principal meteor showers that I sort of picked out to highlight for this year, and it varies a good bit which ones I might pick because of the things like the phase of the moon and how active the showers are and things like that. We had a pretty good one back in January. The January so-called Courantid meteors are are usually a pretty productive shower, and if we have a clear night, then they can be pretty good. And this year was a good night for them, and because the moon was nearly new, and that's what we look for a meteor shower. One of the big things we look for in a meteor shower is that the moon is not in the way, because if it's near a full moon, or even significant lighting from the moon, then it decreases greatly the number of meteors that you can see for a given shower during a given period of activity of a meteor shower. The Quarantids I didn't observe because I remember I was sick that weekend of the just after New Year's there. But the next ones that are coming up that might be worth checking are in May, and that will happen. The peak will be on the 6th of May, and that's the Eta Aquarids, so called. They're going to be good this year because the moon is just before first quarter. It's just a few days before first quarter at the peak of this meteor shower. And so that means that the moon will be setting very early in the evening. And the meteor activity isn't until early in the morning, well after midnight. So the sky will be good and dark by about then. The activity depends on when the Earth, as the Earth orbits the sun, when the Earth passes through the stream of meteors. I need to move this little window over here. Here we have a diagram showing the Earth. You can see the Earth rotating. There, that's the Earth's rotation there, and the Earth is also moving in its orbit, in this case, basically to the right as we look at this diagram. So we're seeing this view from high overhead. At this time, in the period around May 6th, the Earth is passing through this stream of space debris left by a comet. As the comet orbits the sun, it leaves this trail of debris in its own orbit, and where the two orbits intersect, if they do, then we get a meteor shower. And so as the North America here is coming around to the morning side of the Earth, to the leading edge of the Earth here, we encounter the Eta Aquarid stream there, and we see some of this activity out here. It's a little bit misleading that it shows the activity as if it were directed there at the Caspian Sea. In fact, the stream is much bigger than the Earth, and so the Earth is passing through a wide swath of particles that are all reaching the Earth and reaching the Earth's atmosphere in various areas. So you see them from this whole night side of the leading edge of the Earth. You would see them if they were bright enough from the morning side of the leading edge of the Earth, but because of daylight, we don't see those once the sun rises there. So it's this quadrant of the Earth where we see the most meteor activity. So early morning of May 6th is the time to look for the Eta Aquarid meteors. Another major meteor shower during the year, the Perseids that we often look to for a nice performance. They occur in mid-August, so a good time for a meteor shower. A nice warm night still usually by then. Unfortunately, this year the moon is roughly full at the time of the peak of the Perseid meteors, and so the Perseids can be bright, but most of the meteors of any meteor shower are extremely dim, and so the bright moonlight will reduce the number of meteors that you can see enormously, even if you drive out into the country or something. So the Perseids won't be so good this year, although I certainly don't like to discourage people from looking for them, because there can be bright ones. So if you don't mind just setting out your lawn chair around midnight, gazing off into the northeastern sky, you may see a few bright Perseids, but probably not a great year. You won't see a lot of Perseid meteor parties, probably just because the moon is interfering about as much as it could ever interfere. Another nice shower coming along will be the Geminids in December. So now getting into the part of the year where it's not so inviting to set up your lawn chair outside and watch the sky at midnight. But the timing for the Geminids, which is a pretty good meteor shower typically, is still is good with respect to the moon. It's a couple of days before the last quarter moon, and so that means the moon will not be rising um, early in the evening. So you'll have a couple of hours of darkness to watch for the Gemini meteors before moonrise. The moon will be up by midnight, so you'll have a few hours of darkness between sunset and midnight to watch for Gemini meteors. They should become generally more active as the Earth carries us around to the leading edge as we approach midnight. Then we'll have the moonrise and the early morning hours. We probably won't see very many Geminids. So those are some of the meteor showers to highlight for this year. In all of these cases, we talk about a peak, so 3rd of January, 6th of May, 13th of August. But those dates are simply the predicted peak of the showers. In the case of, say, the Perseids, the time that it takes for the Earth to pass through that swarm of comet debris is actually more like 2 weeks. And so the peak is the predicted time when we'll be in the densest part of the peak, but that doesn't mean you won't have a chance to see Perseid meteors for, say, a week, give or take, on either side of the peak. So if you went out around first quarter moon, when the moon will set early in the evening, set by midnight, then you might see some Perseids. So you shouldn't figure that if it's cloudy on the 13th, then you're out of luck. Keep an eye out in all of these cases for at least a few days on either side. And if you happen to be in good observing conditions, consider looking for some meteors. Now, there's another meteor shower possibility, and I've labeled it here a long shot because I don't want to build expectations up too much, but there's a good bit of interest in the astronomical community in what is going to happen coming up this month as a result of the Earth's passage through the debris from a comet, not a very well-known comet. We're not talking Comet Halley here or something, but Comet Schwarzmann-Bachmann 3. Not a well-known comet. It was SW3 for short, right? It's a very short period comet, about 5 years. Halley's comet, which is also a short period comet, orbits are about every 76 years around the sun, and that's considered short. Comets like Hale-Bopp, you might remember Hale-Bopp from the 1990s. It had an orbital period more like 10,000 years. That's more like it. That's more typical. So 5 years, 5.4 years, as it says here, is fairly short for a comet. This happens to be a Jupiter family comet. This is a comet that almost undoubtedly did once have an extremely long period orbit, but through an encounter with Jupiter, ended up in an orbit that keeps it more or less locked to Jupiter. So this is the orbit of the comet, and out here is the orbit of Jupiter. Out there, that's Mars, that's Earth, Venus, and Mercury. Those are the orbits, and you can see that this comet's orbit comes in here to just inside the Earth's orbit, and then goes back out to in the vicinity of Jupiter's orbit, that is, not necessarily Jupiter the planet, but just that distance to the orbit. And it does this every roughly 5.5 years. So this comet was discovered in May 1930. So it's been around for quite a while. Even then, it was an extremely dim comet. It was seen by a few viewers, but it was actually so dim that the comet was lost to viewers for many years and wasn't respotted again until March of 1979, still as a very dim comet. Something was a big challenge for astronomers to find out there. But having been refound in 1979, it was monitored as it came around, as comet watchers do with comets. Every passage nearby the Earth here, which is called perihelion, when the comet is closest to the Earth, to the sun, pardon me, comes in closest to the sun and passes by near the Earth's orbit. Near perihelion in October 1995, there was a sudden bright outburst of the comet. And I think that's what we see happening here. This is the comet at sort of its brightest. Oh no, this was from the outburst in 2006. So there was an outburst in 1995. This is not a meteor shower, but rather that the nucleus of the comet itself had broken apart and suddenly released a whole lot more debris in the orbit that reflects the sunlight. So the comet became brighter because there was far more reflective surface all of a sudden. So that happened in 95. The nucleus had fragmented there. It was quite bright again in 2000, five and a half years later, when it came around in its next perihelion passage. And then again in 2006, when it came by, and this is the comet in 2006, so on its next perihelion passage there. So this comet began to get very interesting in the early 2000s. So here we have it fragmenting back in in May of 2006. And this was, 2006, there it is. This image was taken from the Spitzer Space Telescope, as you can see here, it says. And this is all the material that has been breaking away from the comet and still in orbit around the sun. So we literally see the orbit of the comet illuminated there. And we see the larger chunks, which are both evaporating gases and particles, and also breaking up into small bits here. You can see that there are several distinct nuclei here. So the orbit of the comet gets populated with this debris, and if the Earth passes through this swarm of matter here, we get a meteor shower. But that's not what we're seeing here. Again, we're seeing the comet breaking up and spreading debris along its orbit here. Now, once this material has dispersed, it's more or less invisible, and we won't see it because the density of the matter becomes so low as it spreads out. We won't see it again unless the Earth does pass through the stream, and then we get a meteor shower. So we know then that during this breakup in 2006 and in the previous ones, there were bands of material being left in this swarm spread along the orbit of the comet. So what's been interesting is that just in the very recent past, in the last year or so, apparently, some astronomers have been doing fairly detailed computer models of these invisible debris trails. And the models vary quite a bit from one another. They make different assumptions about the fragmenting behavior and make different assumptions about how the stream will be gravitationally affected by other strong gravitational forces operating in the solar system. But some of them have been making some interesting predictions. Some predict nothing, so that's not too interesting. But others have predicted that the Earth will pass through this meteor swarm on the night of the 30th and 31st of May, with the result that we might get what we actually call a meteor storm, not just a meteor shower, but a meteor storm, meaning meteor counts in the hundreds or thousands per hour. Now, per hour is a rate. They don't necessarily keep on going for an hour. These kinds of outbursts often will only last for a few minutes. And they count the number of meteors they see in whatever, the 10 minutes or something. And then if you multiply that by 6 for the equivalent rate for an hour, you get to thousands. So just because the rates are given in numbers per hour doesn't mean that it will last for hours. It could last for 30 seconds or 5 minutes or something along that line. Nevertheless, it might be worth watching the sky on the night of the 30th and the 31st of May. The conditions are good because the moon will be new. And we'll be looking over here into the eastern sky, not far away from the bright star Arcturus, which I can show you in Stellarium in a minute here. If we see it, then the predicted radiant point is from out here, sort of in between Arcturus and Coma Berenices. Over here, these two, well, Boötes is the constellation where the star Arcturus is located. There's Boötes, Coma Berenices. So kind of in between those two is the predicted radiant point. You don't necessarily have to be looking at the radiant point to catch meteors, because they actually typically occur spread out away from the radiant point just being the point that unifies all the trails. If you extended them back, they would all intersect there. But that's the direction in the sky to look. So if you're going to go out and, like me, assuming that we get a good clear night that night, I will certainly be out watching at around midnight on the 30th of the night of the 30th of May, 31 May, to see whether we get lucky and actually do pass through the swarm of this comet SW3 and get ourselves a nice, if brief, probably meteor shower. So, but I want to repeat again, it's kind of a long shot. If you don't see them, don't call me that I probably didn't see them either. It's but it's a little bit exciting, partly because this capability of being able to do computer models of these sort of complex debris streams in the solar system is a fairly new thing. And it has a lot of implications for other sorts of gravitational modeling, such as predicting the paths of asteroids and determining whether they might be any threat to Earth and things like that. So it has quite practical implications, as well as the possibility of helping us catch a fleeting meteor shower. So again, we can talk about we can answer questions about that in a little bit. The moon this year, aside from those lunar eclipses, the moon is exhibiting a couple of what have come to be called supermoons. Those will be in June and July, and all that means is that the full moon occurs relatively near perigee, when the moon is closest to the Earth, and so that it looks somewhat bigger than average in the sky. I'm sure we'll be hearing about those. They really just pretty much looks like a full moon when you go out and check them in the sky. It doesn't look dramatically bigger, but we will have a couple of them coming up here as we get to the summer. So I think maybe what I should do is switch us to Stellarium so that we can talk about the appearances in the night sky. And so I will just I have to stop the sharing for just a moment, and then switch us to okay, I'm hoping everyone is seeing now the night sky. I'm using that, somebody stop me if you're not. I'm using that software that I mentioned earlier, which is called Stellarium. Stellarium, I like to use Stellarium. It's an excellent piece of software. It is also multi-platform. That is, they make versions for Macs and for Windows, and also Linux, which happens to be the platform I'm using right now. So it will run on more or less any laptop or desktop computer that you're likely to have access to. And on top of that, it's also free. So you can just download it from stellarium.org, and you can do the exact same things that I'm about to do here. Very, very useful for planning observations or just finding out what's currently in the sky. So I have it set for just by default, it's come up for today. And I've got it set for a little bit after 9 p.m., a little bit after 9 p.m. here. So the sky by then is dark, and we see some of the winter stars that we've been seeing here since late last fall. I'm going to talk about constellations in a few minutes. I want to go to planets first, but just over here we see Orion, and we see the constellation Taurus, and bright stars Procyon and Sirius here in Canis Major. So we're looking at a very familiar sort of sky. Let me drag the view around a little bit to the west. And in order for us to see this properly, I need to make a quick change in the horizon so that we get rid of all those annoying things along the horizon, like trees and hills and buildings and things. So if we don't do that, we're not going to see Mercury. So Mercury is beginning to become prominent in the early evening sky. So here I'm well past 9 o'clock. I've got to make it a little bit earlier. And here we are at 8:40, and you can already see Mercury just barely above the horizon there. Let's go back another hour, about 7:42. That's a little bit too much. Let me darken the sky just a little bit here. There's 8 p.m. Okay. So here we are at 8 p.m. actually tonight. Stellarium has labeled Mercury for us over here in the western sky. The sun has just gone down. If you were scanning with binoculars, you might pick out Mercury over there. But it's going to be getting higher in the sky in the evening for the next couple of weeks, until by the end of the month, the viewing will be much better. So let's just advance time then day by day. So there's the 15th and the 16th and so on. And you see that every night as we go forward, at the same time, Mercury is a little higher in the sky. That's because as it's orbiting the sun, it's coming around from behind the sun and swinging out eastward, so gaining distance away from the sun. And as it gets further away from the sun, it stands a little bit higher in the twilight sky. I have to keep, because the sun is also setting a little bit later, I have to keep on adjusting the time just a little bit here. So here we go. We're getting out now into the later in the month, the 23rd. I think the 29th is when Mercury is at its greatest elongation from the sun. So that means sets latest after the sun. But I was noticing here that Stellarium, as I go past like about the 21st and 22nd, that Stellarium reduces the brightness of Mercury. So it might be that the brightest, that the period of maximum, or the time of maximum brightness here is actually more like the 21st or so. So between about the 21st and about the 29th, if you want to try and join the club of people who've actually seen Mercury, the time to do it is between the 20th and the 30th of April. But there are significant challenges to this. One of the advantages of Stellarium, we can just click on it and it will give us a lot of information about Mercury over here. And one of the things to look for is the altitude of Mercury here, which is just under 11 degrees. It says 10 and 58 there. That's not quite 11 degrees. That means 11 degrees above the horizon. Now, if you make a fist and hold it at roughly arm's length, your fist is about 10 degrees high. If you were to set it on the horizon upright, your fist is about 10 degrees. So if when you stretch your fist off in the direction of the west, if your fist is taller at arm's length than, say, any buildings or anything that are out here, or hills or something above the ideal horizon, which is pretty hard to find, then you might have a chance of seeing Mercury. But if those buildings or horizon obstructions are higher than your fist, then probably you're not going to see Mercury at all, because it's going to be, but by the time the sky gets dark enough, it's already too low below the horizon here. So this is the possible window of opportunity for catching Mercury over in the western sky later this month. So instead, let's look at the morning sky, because Mercury, we just exhausted the planets of the evening sky, by the way. We're going to go around to the morning sky now, to the east. And I'm just going to advance time right on through the night until we get to the morning sky. 4 a.m., 5 a.m., there we go. All right. So here we are a little while before sunrise, and now you see where all those other planets are. They're not in the evening sky because they are west of the sun and coming up before the sun in the dawn sky. So all of the other ones that you expect to be able to see, the naked eye planets, the classical planets, aside from Mercury, which is down here on the other side of the sun right now, we have Saturn, Mars, Venus, and Jupiter lined up nicely for us in the early morning sky. So that's what you're seeing. Of course, if you're out these early mornings these days and you see a particularly bright object over there in the eastern sky, that's almost undoubtedly Venus that you're looking at over there. So just as watching the last couple of weeks of April in the evening sky, you'll see Mercury do a little bit of activity for you. Let's see what's going to happen the rest of the month here in the morning sky. So I'm going to advance the time one day at a time and keep an eye in particular on Jupiter and Venus, because you're going to see that by the time we get to the 30th, they're going to dramatically approach one another. Here we are. Until on the morning of the 30th, they reach their closest approach. Now, their closest approach is still not all that close, and even your eye will be able to distinguish them, where here Stellarium runs the two together just a little bit. If I zoom us in, it'll be much easier to see that there's still plenty of space between the two right there. So here we have, this is still not even like binoculars. Okay, now this might be roughly what you might see in a field of binoculars when you can just begin to see Jupiter's moons over here, the Galilean moons of Jupiter, which you can usually pick out in a nice pair of binoculars, and Venus here in the same field. So this is the day of closest approach here on the 30th. Still far from blending into a single object, but what astronomers call an appulse, a close approach of the two bodies. So that's going to be something nice to watch for in the early morning sky. And if we keep on going, we keep on advancing time in the morning beyond April and into early May, then we see Venus continuing to approach the sun, and Mars and Saturn spreading out here. So we'll keep on going a little bit further, and at a certain point, let's see, at a certain point we will, I don't know how far we have to go here. I'm not going to keep this up too much longer, but at a certain point we'll see Mercury appear back over here in the eastern sky. Let's just keep on going and see if I can catch it. Shouldn't take too much longer. There we go. Okay, so we had already found it. It just was too bright. It's just barely made it. So this is nothing. This is not a sight to look for. This is merely sort of a theoretical statement here. But what we have now are all 5 classical planets in the morning sky. Because we technically have Mercury, although there's no way you're going to see that actually that low above the horizon with the sun coming up behind it. But technically, it's over there on the west side of the sun. So we have Mercury, Venus, Mars, Jupiter, and Saturn all lined up in their, even just by chance, their proper orbit distance, in order of their distances from the sun. lined up across here. But notice the stellarium is telling you which ones are nice and bright with the great big dots there, and which ones are kind of obscure. So Mars and Saturn are still going to be not particularly eye-catching, even as we get into here early June in the early morning sky. Well, if all of the planets are over here in the early morning sky, what planets are you going to see at this time as we get into June in the evening sky? Well, the answer is none, because they're all over here. So we still don't have any planets in the evening sky for stargazers to look for. And that's not going to happen really until we get to July. By the time we get to July, so I'm going to advance the time here to July 4th. And then I have to get a little closer to sunrise here. Not too close. By the time we get to July 4th, Saturn will be far enough west of the sun that it'll begin to rise before midnight. So we actually have to wait until mid-July before we have a planet even technically in the evening sky, meaning rising before midnight. So it's actually not going to be until later summer and fall that we have nice planets in our evening sky once again, when they're convenient for seeing at Washburn Observatory or wherever. We will have Jupiter and Saturn well up in the evening sky by August. So if I advance here to August and go back to, well, let's just say a little after 10 p.m. or so. So there we are. So we have Saturn up here now, well up in the southeast. But again, this is still not until August here that we have Jupiter rising over there in the east. Jupiter will, Jupiter will be at what we call opposition, meaning that it will rise at sunset, not until later in September. And Mars, we won't even have in the evening sky until November, and it won't reach opposition, meaning that it rises at sunset, until early December. So the planets, all of those planets for the evening sky is a show that we're going to have to defer until we have a chance to see those in the fall and even late into the fall. So where does that leave us? Well, that leaves us with these familiar constellations that I skipped over just a little bit a little while ago. And so I want to return us now to, well, we'll just make it early May. That'll be close enough. I want to return us now to the evening skies of early May. So here we are at about 9:30 in the fairly near future, looking over into the west. I think I better back us up just another half an hour or so. There, that's what we want to see. So here we are with the evening sky once again, pretty close to what we have now here in mid-April. So as I mentioned, what we're seeing in the western sky here are these winter constellations, these familiar winter constellations of Orion and the many other bright stars that populate the winter sky. By the time the sun is setting and the sky is good and dark, as the sunsets get earlier and earlier, we have less and less of a chance to catch these. The ones that will linger on are the easternmost ones, which we have up here. This one labeled Procyon in the constellation Canis Minor. This bright one up here, Capella, one of the brightest stars in the sky, and these two, Castor and Pollux, in the constellation Gemini. So those winter stars, if you want to get a good look at them, you need to do that in the next few weeks, because they set pretty early in the evening and leave us with the springtime constellations. Now, Stellarium is really good for helping you navigate the constellations. I've just been pointing around here and naming the stars, which it's already labeled, but we can easily turn on the lines that connect the stars that make the constellations and turn on the labels. So if you're not real confident in your constellation recognizing skills, then Stellarium can be a big help with that. And these days, what we're going to find when we start turning over to the eastern sky away from the winter side of the sky, there's Gemini, as I mentioned there, Orion, Canis Major, Canis Minor. Over here, we're looking out into the springtime constellation sky. One thing to notice is that the winter stars are accompanied by the Milky Way, by the winter Milky Way, which crosses right over here through that group of winter constellations that I was just talking about here. The Milky Way is the plane of our own galaxy. When we're looking through the Milky Way galaxy, looking into it, we're looking along the plane of the galaxy, within the galaxy, which is a relatively flat sort of thing, kind of like a frisbee. So we're looking along the thickness of the frisbee from inside of it. When we look over here, we're looking out of the plane of the frisbee, out of the plane of the galaxy, and out into distant extragalactic space. So if you've heard of galaxy clusters, you may have heard of the Virgo cluster is the nearest large galaxy cluster to our own small grouping of galaxies. And that's over here. We can see it because we're looking out of the plane of our galaxy here rather than in the plane of the galaxy. So as you're looking into the sky of the springtime sky, we're looking at the constellations of Leo, sort of a backwards question mark over here. And this extremely bright star Arcturus is a good clue to the constellation Boötes. An old stargazer's trick is to find the Big Dipper up here in the northern part of the sky and follow the curve of the handle of the Dipper. And that curve sort of takes you over to Arcturus. And so generations of stargazers have remembered that by following the arc of the handle, you arc to Arcturus over here. And if you keep that arc going, if you just speed right by Arcturus, you will speed to a star here called Spica in the constellation Virgo. So the arc from the Big Dipper to Arcturus to Virgo is the eastern edge of not the edge really, but the sort of an eastern path through the springtime evening constellations. And the western path through those is marked pretty well by this backwards question mark sort of shape, which is the head of Leo the lion, and the constellation Cancer right here, which is actually has very few bright stars in it. Unless you're in a good dark sky, you can't really see Cancer very well. But that's the region there sort of between the backwards question mark and the nice bright winter star Procyon over here. So we can be exploring the sky with star charts or Stellarium, and I'll consider this just sort of a sampler here of the things that we'll be looking for in the winter sky, things to aim our telescopes at, things to enjoy with our binoculars, and suggest that for the rest of the year you should get a hold of Stellarium or some other aid for stargazing. There's still plenty of good printed sky atlases and things too to help you find your way around the sky, and use those as a guide to watch in the summer and autumn skies. I'll also toss in one more thing before I open it up to questions, and that is that speaking of stargazing, the last couple of years we've had the Washburn Observatory on the UW campus closed for pretty much obvious reasons, but we've just started resuming the public nights, the public visitors nights, which are a very long and honored tradition in the astronomy department at UW. The schedule has been the first and third Wednesday nights of each month if the sky is clear, and that schedule started in April of 1881. And except when it's cloudy, which is the usual problem, or if something is broken and needs to be fixed at the observatory, The department opens the observatory to the public on the first and third Wednesday nights of each month. So watch for those opportunities as well. If you don't have your own telescope or you want to look through an old historic telescope, Washburn Observatory is open to you on that regular basis. So with that, I will turn it back over to Joy, and we can take any questions that you might have. And thank you so much for the opportunity.
Well, yes, thank you very, very much. And if my lights go out, it's just because the wind is really picking up and my lights have been flickering the past 15 minutes. So hopefully the power lines will stay in place for another 15 minutes or so. If you have a question, post it in the Q&A section and we'll get to as many as we can in the next 15 minutes or so. Before we take questions from our attendees, I did want to ask you, Dr. Lattis, about the Northern Lights. I saw up in the UP within the last week, they had a show of the Northern Lights. Can you briefly talk about what causes the Northern Lights and how we sometimes see them, as far south as Madison, even more south than that?
Sure. So the Northern Lights are a result of solar, of energetic particles from the sun, primarily electrons, that reach the Earth's atmosphere. Now, most of the particles from the sun actually blow around the Earth, are deflected away from the Earth's by the Earth's magnetic field. So otherwise, we would see auroras all the time. But we only see them when they're particularly energetic puffs of these particles that can penetrate down to the Earth's, to the upper reaches of the Earth's atmosphere. So that takes an energetic event from the sun, like a coronal mass ejection or some sort of energetic event, usually associated with sunspots, although not necessarily. And when there's such an eruption from the sun and that cloud of charged particles, if it's going in just the right direction to intersect with the Earth, and if the timing is just right, then those particles will reach the upper atmosphere of the Earth, and the high energy electrons will energize, say, oxygen atoms and nitrogen atoms, and they then emit the light. So we're really seeing light from our own atmosphere that's generated by these solar wind, or really solar gust, solar storm particles there. And they're as hard to predict as the weather is. We can, excuse me, we can see those when those events happen on the sun, but we can't always predict exactly what that path is going to be and whether it will intersect with the Earth. So we get these forecasts that are reminiscent of weather reports, a 50% chance of auroras tonight or something along that line. And they do happen, and then they happen in a complicated and still very hard to predict interaction with the Earth's magnetic field and its atmosphere. So it's very hard to tell just what part of the Earth, well, except that they're almost always going to be near the poles, far north. But whether it will be seen over the Upper Peninsula or over Finland is much harder to predict.
We had a question from one of our attendees who said that there was a recent report about a peek into a black hole. He wrote peek, P-E-A-K. Can you share more information on this discovery and its implications?
Well, unfortunately,
is there something new when it comes to black holes?
I haven't seen anything real recently. There was maybe a year or more ago results from what they call the Event Horizon Telescope, which is actually a collaboration of a bunch of terrestrial telescopes making radio observations of distant black holes. So they were able to discern details around the event horizons of a couple of massive black holes. Well, I think maybe really just one, although we're expecting some results about the Milky Way's massive black hole fairly soon here. So no, I don't know of anything real recent on that. the possibilities are pretty remarkable, though, that we can begin to piece together information about these sorts of things at that kind of scale. They maybe the most important thing is that those observational results agreed with the theoretical predictions.
Mary wants to know if you have more tips on best viewing sites outdoors at night, maybe in the Madison area. In any city, how far away should we be from city? And I assume city lights.
Well, that's a difficult one. You want to be as far away from the lights as you can be, or as is practical for you. So there's no magic number in that way. It depends on what direction you go away from Madison too, how quickly it becomes dark over on the north side of Lake Mendota. It gets dark fairly fast. The best general advice I can give is that the county parks will give you a stargazing permit that allows you to stay in the park past closing time, and I think all night. So those are good options, because the sky at like Ph.D. Park and Donald Park over in western Dane County, those are some nice, within reason, those are some nice dark skies. They're good skies for meteor observing and things like that. So either that, or you just have to know somebody who lives out in the country who's willing to give you permission to camp out on their land. But no, investigate the stargazing permits at the county parks. They're a good option.
Yeah. We have you did talk about the Perseids in August. One of our attendees says that she and her husband love to watch, I think it's the Perseids every August. You said this year, though, it may not be as brilliant because it's too close to a full moon.
Right. Yeah, it coincides pretty close to the peak. The peak of the shower coincides with the full moon. So basically, the moon is up all night when it's full, and so we'll have moonlight detracting from the meteors pretty much all night. So getting out ahead of the peak when the moon is still setting in the evening hours, by around midnight or so, that you're getting further away from the peak then too. So yeah, it's just not a great year for the Perseids. I wouldn't plan a vacation around it. That doesn't mean that you shouldn't still check it out and see what's happening, because we could have a really good Perseid year, and if there are lots of nice bright ones, you'll see them even though the moon is out.
And someone wanted you to repeat all of the meteor showers and their peaks. I think that maybe I don't know if you can briefly do that. You can also refer back to the recording. This lecture was recorded, and it will be on the platomadison.org website. So you can look at all of the information. There was so much going on.
Well, and I only picked a few examples. The Eta Aquarids are early May 6th, I think was the date. And the Perseids are always right close to the middle of August. The 13th is the peak this year, but it's always roughly that. And let's see. Oh, the Geminids were early December, roughly December 6th. But these are all very common, well-known meteor showers. That nothing I said there is any big news, except for the long shot of the SW3 comets. And that's on the night of the 30th and 31st. Around midnight on the 30th of May, early morning 31st of May. So those are just the dates that I had put up there. You can easily consult all kinds of things for meteor showers. There's several. There's always a meteor shower going on. Most of them are pretty light duty things, not very many meteors. A lot of you have to be a real aficionado to want to pick up on some of them, but you can find plenty of sources for those. And if you go to the universalworkshop.org, one of the first website I gave. He has lots of good information there in his astronomical calendar. In fact, I think I would recommend that as the single best source for all of this kind of stuff: meteor showers, comets, constellations, planets, eclipses. He handles it all.
Steve wants to know, are governments tracking large meteors that might strike the Earth? Can they be moved or destroyed as seen in the movies?
Certainly they're being tracked. And in fact, there was just a really recent example of a relatively small one that was spotted a couple of days out, and its time of impact on the Earth was predicted quite accurately. Um, it was a small one, not one that anybody would worry about, but it being able to detect it in advance and predict where it would reach the Earth is a big accomplishment and very encouraging. So yes, governments, primarily NASA, tracks where these objects are in the solar system. Um, we have telescopes that do patrol the sky, but the limit is the size, is the brightness of the object that we can detect with a given telescope. And so a bigger telescope devoted to that kind of thing will find things further out, but the patrol telescopes tend to be relatively small. Um, and so what we would like to do is be able to detect the big ones further out, because the big ones are the problem. The big ones are the ones that might potentially have an impact on us. At the moment, astronomers in that area think that we would, for seriously dangerous asteroids, we should be able to at least predict them months to years in advance, that to predict them as threats to the Earth. Being able to do anything about them is another matter entirely, and that's an area of active research. As of right now, no, there's basically nothing we could do about a serious impact. But there are tests underway. In fact, there's a NASA spacecraft on the way. What's that called? Double asteroid. I can't remember now. It's DART is the name of it. It stands for a double asteroid test. They're going to actually slam a small spacecraft into a small binary asteroid and see what the effect is on the orbital period of the two bodies that are orbiting each other. And this will be the first attempt to actually change the dynamics of orbiting bodies in space. So we're very, very early in our ability to do anything about this. But out of such things, yeah, eventually we might be able to do something like what they do in the movies. But we certainly need to keep on working on that before we have a practical ability to do that.
Another attendee wants to know if there are eclipses, I guess solar or lunar, in another part of the world where we can't see them. Can we see them on video, or can we see them live? And do you have any recommendations along those lines?
Um, so yeah, for example, with a good solar, if there's a nice total solar eclipse, which there isn't this year, but if there were one and it's occurring on the wrong side of the Earth for us, then yeah, it's very common these days that there are live video feeds from observatories in the area that can see the eclipse. That actually happens quite frequently now. So the thing to look for is for the big planetariums or observatories where the event is happening that you're interested in. So back, now I don't remember what year it was. Quite recently, there was a nice solar eclipse, and a bunch of the like the Adler Planetarium and the Griffith Observatory out in California were picking up feeds, and NASA was doing it too. And you could go to various places and follow those events live. So that's becoming quite common, certainly for eclipses, and we may see it then for other things as well, like occultations and things like that are currently a pretty specialist interest. But it becomes easier and easier for them to live stream these sorts of things. And so we'll probably have a lot more access to distant astronomical events than we do now. Unfortunately, a lot of the real spectacular things, like say the Northern Lights, are diffuse and low intensity sorts of things. And so it'll probably never replace being actually in the sky, seeing those things over your own head in the sky. But yeah, there are live streams of astronomical events that are happening more and more often.
We are, we're out of time, but time for you to, one more repeat, the lunar eclipse coming up on May 15th. You will be at the UW Arboretum and doing or is the UW Arboretum going to do that without you?
So the event happens regardless of what any of us do, of course. You better check with the Arboretum. My recollection is that we are doing an event there, which really just means we'll kind of all be watching the eclipse together. I might set up a telescope, but by all means check the Arboretum event calendar, because it's really up to them if they were to decide they don't have staff for it or something along that line. It might not happen, but watch for that and check with the Arboretum. And yeah, certainly on that evening, if it's nice and clear, we may have that's a fairly good spot for an event like that while you're still in the city anyway. But we don't need super dark skies for a nice lunar eclipse. So, right. But check with the Arboretum, please.
Will do. And if it's happening, maybe we'll see you there. Thank you so much for being with us today.
It's my pleasure.
Thanks to our speaker. Lots of great information. Jim Lattis is the founder and director of the UW Space Place. And thanks to all of you for attending this lecture. You can check out our website, platomadison.org, for more information on some upcoming events. There is a breakfast get-together on May 13th. There's info on Plato's summer courses and registration. And we will have this lecture, and our other past lectures are also posted there. On behalf of Plato Madison, I'm Joy Cardine. Thanks very much for being with us. Happy stargazing. Bye.
Are we all done?
We are. I'm looking to end the.
Okay.
Yeah. So.
All right.
Thank you very much. That was great.
Thanks for all the support.
Thank you. We'll see you.
I'll check out then. Bye-bye.
Bye.